Sure.
Okay, so now coming in.
We have the mask.
Okay.
Don't have to.
Okay. Okay, so let's review about the encapsulation. Right? The encapsulation, you have everything about the application layer here. So when you send it down to transport layer, right? So when it down to transport layer, normally you have to break it up into multiple segments here. Right? So we can think about when we send the whole email, it's too much data, it's too large. You have to break it up into multiple segments here. So think about we have the one segment. When you send it down the transport layer here, you have the header here from the transport layer. So what do you think? What in the header in the transport layer? What do you think? What information you have in the header in transport layer?
IP address.
Any idea?
IP address. Looks like this.
What do you think? IP address is not correct. What do you think? What information in the header of the transport layer you have? What do you think?
Port number?
Sorry?
The port number?
Yeah, the port number. The correct one is the port number here, right? So basically, here's the port number. Remember, port here is a logical port. So by using the port number, what is it? Why do we need to use the port number? What do you think? Why do we need to use the port number?
Guide it to the right
application. Yeah, right? Because you see, you have the one computer here, and you only have one physical cable, right? You only have one physical cable here, but at the one time, you can have the email, or you can have the World Wide Web service, or you can have the voice over IP. Right? So each of them, they have specific port. They say for the email, we have the port number 25. For World Wide Web, we have the port number 80. Or voice over IP, you can have other specific port here. So you see, it can route it to the correct application here. Right? So now, when you send it down to the network layer, you see, you send it out everything to the network layer. You have information here from the network layer. So what header information you have in the network layer here? What do you think? What information? You said IP address. Yeah, the IP address is that it tells you how can you reach to the final destination. Right? So you see from the computer here, in order to reach a destination, you can go to many ways. You can go to many ways, go to the destination, or go on this way here. So by maintaining the IP address here, the router is always tell you which way is the best way to reach the destination. Right? So what at one time it can go on this way, it's the best way, but other time it somehow with congestion here. The router route you, that is the best way. That's why you have to maintain information about the IP address here. It's the network information. Now, when you send it down to data link layer, to the data link layer, what information here you have the header. Remember that data link layer, you have both of the header and trailer here.
MAC address?
Yeah, MAC address here in the header, right? And the MAC address here is UVO in the local network only. Remember that local network, right? So from here, if you want to send the destination, you know for sure you have to send it to the default gateway here. That is local network. So now you go to the router. Router knows that in order to deliver to the destination, you have to deliver to another router here. Here again, it's the local network. Right? So you see the IP address here stay always the same, but the MAC address here change step by step, right? And the channel information here is everything about error detection. So if something is changed during the transmission, it can detect it, and discuss somehow here. Okay, now for the transport layer protocol, on the last class here, we talk about the transport layer protocol. You have the two major protocol. You have the two major protocol in the transport layer. What are they? Yeah, you have the TCP, and UDP. TCP is transmission control protocol, and the UDP is the user datagram protocol. So what is different with some? What's the difference between the TCP and UDP here? Sorry. Yes, this one is a connection oriented. Connection. What is a connection oriented? That means before you transmit it, you have to handshake it. Right? You have to agree. You have to agree that if the destination here available or not, you have to agree that how much data how much data you can send. You have agreed that available or not, how much data you can send, and you also have agreed on somehow about the acknowledgement here. Acknowledgement here. So think about this one. Just remember, connection oriented. That means before you transmit, you have to handshake with destination. You have to agree that he available or not. How much data you can send. I think about if you send too much data and he is not able to handle it, overload it. So we have to slow it down. That is everything. The call is a sliding window here. So remember TCP here, connection oriented. Connection oriented. You have the handshake before it. For UDP, you have this call is a connection link. You don't have the handshake. You just send it out as much as you can. You don't care. You don't care if the destination here available or not. You don't care if the destination able to handle or not. You don't care if the segment here, right? Is segment here, they come in the right order or not. I see when you send it to the destination, maybe you have the number 2 first, and number 1, number 4, and number 3. They are not always on the same order when they receive it. So that is UDP. He don't care if you receive it or not. He don't care if they come in the right order or not, or he don't care if somehow you lost the transmission or not. He don't care. So the question here, why is this one here reliable? This one here reliable, right? This one here reliable because here you have to check if available or not, and you have to maintain acknowledgement here. So whenever he receive it, whenever destination receive it, he have to send it back here with acknowledgement here. He confirm that I already received for the segment number 1, segment number 2, and so on. So whenever in the TCP here, whenever you send it out, you always have the timeout here. You have the timeout setting here. Think about you set the timeout setting at 30 milliseconds, right? So here, when you send the destination, so within the 30 milliseconds, you will receive the acknowledgement from the destination sent back. You understand that you already received it successfully, right? And if more than 30 seconds, but you don't receive any acknowledgement here, you understand that something going wrong during transmission here. So if you don't receive any acknowledgement for the segment number 2, you just transmit it again for the segment number 2 here. Right? That the code is a sequence here. The code is a sequencing. Sequencing, that means you put the number here, put number 1, number 2, and number 3, and so on. Right? So we see when you maintain the sequence number here, you have some benefits. The first one is that you make sure that if the destination here receive it or not. In the case not receive it, you can retransmit it. That's the first one. The second one is by maintain the sequence here, you can make sure that you can reorganize it in the original order. You can put it in the original order here. And the sliding window, that means before you transmit, you have to agree how much data you can send at one time. I think about you can send for 500 bytes per second here, but somehow the destination is overloaded. He can tell you that you have to slow it down, and you can slow it down to the 300 here. That's why they call it sliding. That means adjustable. It's adjustable. One time you can transmit for 500, the other time you can 300. But if the network is good, you can increase it to the 800 here. And that's why they call it sliding here, adjustable. Okay, so now you know that the UDP and the TCP here is the 2 major protocol. And remember, here's this one here. Remember about the TCP, it's reliable, reliable. And this one, no reliable. And reliable because maintain everything about the sequence number, acknowledgement here, handshake here, right? This one, you don't care. So the question is, why don't you use the reliable here? Why don't you use TCP instead of UDP? Why?
Like video of YouTube help.
Yeah, that depends. It totally depends on application. It totally depends on application. If you need something very fast, you don't care about something. It's not really tolerate for any delays. You have to work with UDP. The thing is that UDP, you see, when working UDP here, that is data. You have very, very small amount of header. It's only about the the port number away. Right? But in the TCP here, you have the same data, but you have the more header here because you see you have the port number, but you also maintain everything about sequence number, sequence here, and acknowledgement here. Right? So see, when you have more header, that means you have less efficiency when you transmit data. Right? That's why this one here, more efficiency when transmit data. That's why it works very fast. And it depends on the application here. So if you work with the voice over IP or video on demand, you need to work with the application, UDP here. But when you need something reliable, right? Say you want to send out the email or you want to have the web server here, you have to work with the TCP here. Okay. Now we talk about in deep about the TCP here. TCP, you know that is the connection oriented, but that means before you transmit, you have to handshake with the destination here. And they call it a three-way handshake here. Three-way handshake. What are they? What are they? You have the source, you have the destination here. What is a three-way handshake? What are they? What are three messages in the three-way handshake here? Any idea? The first one, what is it?
Is third one acknowledgement, or am I thinking of something different?
No, it's not acknowledgement. It's a sync. Sync here. Sync. That means synchronize here. Yeah, sync. Now, what is the second one? What's the second one? Yeah, what is the second one? Yeah, the second one is a sync and act. And the third one, you have act here. Act, that means acknowledgement here. All right, so I see you have the sync and act.
Oh, I got them in the wrong order.
Okay. Now, so what is the sync and what is the act here? Let me show you what is the sync and what's the act. So remember that in the case of TCP, you want something reliable. You have to handshake before you transmit it here. So the thing here to tell you, the sort here tell definition that I want to transmit data. And I want to starting from the number, I want starting from number 100 here. The reason that they don't want to starting from the 0 here because of security problem. So when the guy know what is starting sequence number here, he can hijack into the packet here. So that's what here. The sequence number here for each of the connection, it generates randomly from the 32 bit, here. It generates randomly. So one time it can be 100, or other time it can be 1 million or 2 million, whatever. It always random number generate randomly. And the reason that generate random because of security problem. Okay. So now, at the beginning, this guy here want to start the transmission. He generates the random number 100 here, right? You think about this one. I want to start the connection. I start from the 100 here. So think that one. When this guy receives the sync request from the source here, he will send out acknowledgement here. Acknowledgement that confirm. Hey, I already received the sequence request from you 100. And now I expect the next one is 101 here. That's why whenever you see the acknowledgement here, it always one number greater than this one. So see, I received the 100 request already, and now I expect the next one here, 101. It's come from the acknowledgement here. And also this guy also, he want to send the data also. Again, he have to generate his own unique sequence number. It might be the 200 for this one here. You have to might be 200 for this one. So now, what do you think? If this guy receives the 200 requests sync here, what is acknowledgement number here? 200. 201. 201. Because he received that, he confirmed, I already received the request for 200, and I expect next one here is 201. So see, this one here greater than this one, 1. And this one here greater than 200 here, 1. That is the process of three-way handshake. You have the sync request here, you have the sync and act. Act here is a confirm for this one. and sync it from his own, right? And now this guy act here. So now, when you reach the complete the three-way handshake, that means you agree on everything, right? You agree on the sequence number, you agree on acknowledgement number, you agree on the sliding window here. And now you can send the data from the source to the destination here and back and forth here. Okay. Any question for this one? Hello?
No questions.
Okay. So that is a TCP setup, right? So a three-way handshake. But in the case if you want to terminate also, in the case if you want to terminate the connection, you also have to agree. You also have to agree here. All right? So in the case of terminate here, what do you have? What do you have to send from the source to the destination here? You have the two of the two-way. You have the two of the two-way handshake, not three-way handshake. You have the two of the two-way handshake here. What is it? All right. So we have to send the first one. You have to send the fin request here. Fin that means finish. All right. So when receive it, you have to acknowledge here. I already confirm you. I receive it. You have to this one again. You have to terminate it from his side. That's why you also have the fin here. And this guy here receive it. He confirm I can. All right. So see, you have the two of the two-way handshake. Fin and I. That's why they call the two of the two-way handshake. All right. Okay. So I think it should be better if you look again at the slide here. Okay, so now if you see in the encapsulation, if you look on this one, that is the process encapsulation in the TCP here. You see, the data here is come from the application layer. But in order to deliver data, you have a process of encapsulation here. Everything here is a header. See, everything here is a header, right? You see a lot of source port here, destination port, sequence number, acknowledgement here. You have a sliding window here. That is the process of encapsulation here. So we see from the data here, from the application layer, but in order to deliver it, you have the huge amount of the header here, So when you can compare this one with UDP, you can see what's the difference here. Let me see. Let me show you UDP here. Yeah. No, not this one. Oh, I don't have the UDP here. Let's check. Sorry. But for the UDP, you can see in the UDP here, actually for the encapsulation of UDP, in encapsulation UDP, you don't have anything with this one. You don't have anything with the sequence number. You don't have anything with acknowledgement here and the sliding window here. That's why in the encapsulation of UDP, you have a tiny small amount of header here. That's why it's more efficient when you transmit data. Because in the trade-off, you lose everything about reliability here. Right? So now that is the UDP. Now you can see about the three-way handshake here. That is a three-way handshake. You have the sync, you have the sync and act, and you have act here. So you look on this one here. If you look on this one here, start with the sequence number. I want to start with the sequence number 100. So see, when he receives it here, he have to send out actually number 101 because he confirmed I already received the request for 100. I expect next one here is 101. Again, from his own, he generate his own sequence number 300 here. I see when this guy receive it and he acknowledgement here, he send out right acknowledgement here 301. And of course the sequence number here is 101. And for each of the message here, they have the flag. They call it the flag. They call this one here the sync. That means the sync message. This one here you have the sync and act message. And this one here you have act message. Now you can look it back on this one here. All the flag here. So you can see when you work with a Y sharp, you can see what is the flag you have. You have the sync, you have finish, or you have acknowledgement. We will work with the Y sharp, I think, on this class today. So you see how clearly it work with the white shark key. Sorry, with the black key. Now that is a three-way handshake. Before you transmit it, you only have the handshake. You have three-way handshake. Sync and I key. So now in the case, so okay. So this one here. This one, when you capture with white shark, you can see there it has the flag here. It has the flag here. So when we see you set the sync here, it's a sync request. It's the first step in the three-way handshake. You see the flag here set it one. That means you set the sync request here. Okay, so in the case if you want to terminate it, you have the two of the two-way handshake here. You have the two of the two-way handshake. Two of the two-way handshake. You have the fin and X, and you have the fin and X here. You have the two-way handshake. Now, so far we go with the transport layer already. So that you will have encapsulation here. From the application, you go down to the transport layer. So you know that in the transport layer you have the TCP and UDP. So now when you send from transport layer, when you send it down to the network layer, you have encapsulation here. You know that is the IP address here. So for the IP here, again the IP here again it is unreliable and connectionless protocol. The same with EVP. They call it the best effort here. The best effort. Oh, the best effort, that means when you got the data, you try to send it out. You try the batch, you try the batch here, but you don't care if they come to the destination in the right order or not. You don't care if the destination available or not. You don't care if there's something lost during the transmission or not. So if you want something reliable, you have to totally depend on the transport here. You have to depend on the TCP here. That's the way it works. Okay. So basically, in the see that is everything about the encapsulation of the IP packet here. That is encapsulation of IP packet. So you have this one here, referential service. I am not really good at pronouncing this one. And or what is it? Service here. Or they call it sometimes they call it a QoS here, quality of service. The quality of service. So tell me why do you need to maintain the quality of service? What do you think? Why do you need to maintain the quality of service?
Priority.
Yes, set the priority. Right? So something about all of you share the same cable here, right? Sometimes you have the congestion here. Right? So you have to set the priority for the application for the service here. So think about if you need something with a voice over IP, you need to go very fast here. Right? So you have to reserve the bandwidth for that. So you have to, whenever you have the voice over IP, you have the first priority to go first. The same when you have the congestion here, the police car or ambulance, it has the first priority to go first, right? That's why you have to maintain the quality here. And you see the two most important field is the source and destination here. That is the IP address here. Right? So that's why you only have to maintain the source and IP address. And remember, IP address here always stay the same. During the way from the source to the destination, never change. But the MAC address change step by step here. Okay, so in the encapsulation, the IP also, you have the field of the time to live here. What is the time to live and why do we need to use the time to live? What do you think? Time to live here. Why?
I didn't quite catch the question.
Here, the TTL here is the time to live, right? Time to live. So what is the purpose of time to live? Why do we need to maintain the time to live field here?
So if a message got stuck somewhere, it could not loop forever.
Yeah, right. The purpose of time to live that, yeah. You see, somehow you have the something wrong with the routing. You see that in the case of of the router here, right? You have the router here, you have the source. You send to the router 1 and send to the router 2, and you expect that it send it to the destination here, right? So here, if you something wrong during the routing, right? So router 1 thinks that in order to deliver to destination, it send it to the router 2 here. But the router 2, something wrong with the routing, right? He send it back again to the router 1. And you see, it again forever here, right? If you don't maintain the time to live here, it go again forever. It infinite loop here. So we see when you go again forever, you assume a lot of bandwidth here. You have something, the first thing is the bandwidth. The second one, the processing here. Whenever you receive it, you have to do everything with the de-encapsulation. You have to open the envelope. You have to do everything with the de-encapsulation and encapsulation here. That's why you maintain the time to loop. So in the time to live here. So in the case of the time to live, whenever you send it to the router or the computer, when you send it to the router or the computer, the time to live here decrease by 1. I see it is starting here, is starting it set the time to live here. At the beginning, if you set the time to live here, 555. Right? So when you reach the router 1, you decrease it by 1. You have 250. You have the 254, and over here you have 253, and you go here you have the 252 here. Remember that whenever you route to the router or computer, the time to live here decrease by 1. So think about in the case of the endless loop here. Endless loop here. When you reach to 0, the packet will be discarded, will be dropped here. So it prevents the problem of endless loop here. It makes sense. Whenever the time to live reaches 0, the packet will be discarded or dropped here.
Like reality.
Yeah. Okay, so now in the network layer, you have in the network layer you have some protocol. You have some protocol here is the network layer. The first one is the IP here. IP, you know how to encapsulate. The second one is the ICMP. ICMP is the Internet Control Message Protocol. In the case if you want to do the troubleshooting or you want to verify the connectivity here. So the ping message, right? The ping message it also belongs to the ICMP here. You know that the ping message you want to verify if you are able to reach destination or not, right? Or you can have the JSON message also. JSON message is tell you step by step how it go from the source to destination here, and of course you have some other message here, and you have some you have one more protocol. It's ARP here. ARP actually is a layer 2, but it works in the encapsulate in the layer 2 here. ARP. What is the ARP? What do you think? I explained this last time. I have the simulation for that also. What is the ARP? And why do we need to use the ARP here? What do you think? Any idea how and why do we need to use the ARP message here? Protocol here. ARP is address, yeah, resolution protocol. Address resolution protocol.
Isn't it for when you need to like convert IP addresses between Ethernet cables?
When you want to find out what is the MAC address. So now, if you see the process when you deliver from the source to the destination here. Yeah. Now think about this one here. You have the source here. You want to deliver to destination. Destination here. So you see, you have along the way. You have router 1, it's a gateway here, and you have router 2, and so on here. Now to make it simple, I just have the 2 routers here. I see what's this one. For every step, you only have to do the process of encapsulation and de-encapsulation. So see this one here. Think about I have the IP address here, 192.168.1.10. And this one here, I have 172.16.1.10 here. So the first step here, the first step of this one is that for the source and destination here. This guy here, he knows that the destination here is not on the same network. The IP address is not the same here. This one 92.168.1 and this one here 172.168.1 here, not on the same. So we see, in the case of the same net, not on the same network, what is the first step you have to deliver it? What is the first step you have to deliver packet to? What do you think?
The gateway.
Yeah, you have to deliver to the gateway, right? You have to gateway. You see, you only have one way to go out. So even that you go to somewhere here, or you go to somewhere here, or somewhere here. The first step here, you only have to deliver to default gateway. But here, if you want to deliver to default gateway, you have to process it in encapsulation. So see, you put the IP address here. You put the IP address here. The destination here is 172.168.1.10. And this one is here, .1.10 from the source here. That is the IP address, right? But when you set it down to the data link layer, you have the encapsulation about the destination MAC address and the source also. And remember that the destination MAC address here only in the local network only, and you got it from interface here. Make sense? You have to make it here. You have to get it and you put it here, destination, and the source is your here. Make sense?
Yeah.
Okay, let me open it again. I think I have to do it again. Yeah, this is if you look again about this one, if you look about this one, that is the case you deliver on the same network, local network, right? This is a local network. Remember that in the case of local network, you can directly communicate together. Right? So see, in the case of local network here, in the case of local network, you got the source here from you, and what's the destination? So not this one. Sorry, I have to come back to the other one. Yes, this one. That is local network here. So see, you want to deliver it from this guy to this guy on the same network, right? IP address here, IP address on the same network. So in the case of the same network, remember that IP address here always stay the same, never change. But the destination here, you can directly take it from the destination. And the source here, you take it from the source and you encapsulate it. But what happened here? What happened here at the beginning is this guy here. You know that I want to deliver from my computer. I want to deliver to 192.168.1.9. That's in that case, you know the IP address here. You know the IP address, but you have no idea what is the MAC address. You have no idea what is the MAC address. So that's why you have no information you put in here. You have no information you put in here. In that case, you have used the ARP here. ARP is the address resolution protocol. So it is in the case you know the IP address here. You know, take it, but you don't know the MAC address. You don't know MAC address. So in that case, you have to use the ARP here. ARP is the address resolution protocol. So the first step, you have to send out broadcast message. Broadcast, that means you send it out to everyone on the same network. I send it out to everyone, and you raise a question here. Who is 192.168.1.9? Who is 192.168.1.9? So we think about this one. In that one, you have many computers connected to street here. So when we send a broadcast, we send it to everyone. Send to this one, send to this one, send to this one, and send to this one. But all of them is not correct, right? This one is not .19. Drop it. This one, drop it. This one, drop it. Only this guy here is the correct one. .19 here. So he know when he receive it, he understands that this one here want to know my MAC address. So he will answer you. I am 192.168.1.9 and my MAC address here, CC. So when you receive it, now you can encapsulate it and you put the CC here and you send it to the destination here. So that is the case of on the same network. Now in the case of the remote network, right? You say in the case of remote network here, you can see this one here, and this one not on the same network. You know that you have to send it to the default gateway. And again, you know your default gateway is 192.168.1.1 here. So in that case, you encapsulate it, but if you don't know your destination here, again, you have to send out the ARP message. Send out who is 192.168.1.1. And this guy reply you, I am 192.168.1.1, and my MAC address here, 1111. So in that case, you put it in the destination. Make sense? Okay, so that is ARP. Okay, so that is the case here. You can see how the ARP work here. You can see how ARP work here. So basically, the first step when you want to send the destination here, the computer will figure out if the destination on the same network or not. That's the first step, right? And if in that case, if they're on the same network, you need to know what is the MAC address of the destination computer, right? And it's in the case of the not on the same here. You see, think about this one. I want to send from this one to this one. You see the IP address here, they are on the same network. So in order to do that, I have to put the encapsulation here. The IP address, and I need the destination MAC address and the source MAC address here. So we know my source here. I make it I make it simple. I have a 6 EED here, and destination. So if I don't have the destination, I have to use the ARP here. So the first step that my computer here, it maintains the code is the ARP cache. ARP cache maintains the mapping between the IP address and MAC address. It's MAC address. It's mapping between the IP address and the MAC address here. So the first step, I look in the ARP cache here. If I already mapping between the 192.168.1.20 with this one, I just take it out and I put it here, 1D07 here. I send it directly. Send it. But if I don't have here in my cache, you have to send out the ARP here. You have to send out the ARP here. Okay, now let me do the simulation again so we can see how it works here. Okay, you can see how it works. So let's see. I think I just bring it here. Now let me do it again. So now we see how it works with simulation here, right? So the first step here, I want to ping to the 20. I have to look it up in my cache here. ARP, I can check it by ARP right here. So you see, I already have the mapping. You see, I already have the mapping here between the 20 and 1D07 here. So I don't have to send out the ARP anymore. You can see that. You can see with simulation here. Where am I? Here. I bring it here. So we see the first step here. You look at this one. I already have the IP address here, and I already have the source and destination here. I can directly communicate. I don't have to send out ARP, right? Because I already have information in my cache table. Right? It makes sense? Yes. So now what happened here? I can write this one. What happened if I don't have here? I simulate it, I delete it. I delete the table here. Right? So now I can check again. I don't have any information. Right? You see, I don't have information here. I don't have any information for the remote here. So now what happened if I want to ping it here? I ping again. Okay, so now see, instead of send out the ping message, you have to send out ARP here, right? You can see, you send out the ARP here, and you see the destination here. You see the destination here, I have the 12-digit app. So whenever you see the 12-digit app, that means I send it to everyone on the same network. Everyone on the same network. Okay, the broadcast. So what happened with the broadcast here? You can see what happened with the broadcast here. See, send to the switch. Send to the switch here. So what happened? Switch send it to everyone. That is because of a broadcast, right? Send it to everyone. This one not 20. This one not 20. This one not 20. They just discard it, drop it. Only this guy here. So you see, only this guy here, the 20. He answered it. He answered it here. And of course, his answer, he already has the IP address and the MAC address here. So now, when it comes to the computer, when it comes to my computer, now I check again. I check it again. Sorry, I had to come back. Yeah, I check it again for my cache table here. You already update it here. That's why from now on, I just send the ping directly. I don't have to do anything with the ARP message anymore. Okay, it makes sense.
Yeah.
Okay. Okay, so do the same. In the case if you want to send from here to here, the first step you have to send it to the phone gateway. And if you know the IP address of the gateway, but you don't know the MAC address of the gateway, okay, you have to do the ARP message. Now the last process in the encapsulation is that when you send it down to the data link layer, when you send it down to the data link layer here, you have application here. Sorry, you have application. When you send it down to transport layer, you have the header. When you send it down to the internet layer, you have the header. Now the last step is the data link layer here. Remember, you have a both of the header and channel. Channel here is the error detection, and the header you have to insert the MAC address. And I'm not really sure. Do you know how the format of MAC address? How many bits? 32. 32 is for the IP version 4 address. And this one here, IP version 4. For the MAC address,
there's 16 bits.
48, right? You have the 48 bit. Yeah, correct. You have 48 bit. You have 48 bit. But it represents by 12 hexadecimal. The 12 hexadecimal, because each, you see, one hexadecimal here, one hexa. You need 4 bits. You need the 4 bits for one hexa. That's why 48 bits here you represent by 12 hexadecimal. So for the 48 bit here, again it breaks it down in 2 portions. The first one is the OUI. The second one it has the serial number. What is the OUI? What's the OUI here? You have the 24 bit for this one, and they have 24 bits for this one. Yeah. Organizationally, unique identifier, or you can think about the manufacturer or vendor here to make it simple, right? It can be Cisco, or can be Dell, or can be HP, or whatever. Right? And serial number is a unique number in each of the vendor here. Right? So when you combine both of the vendor and the serial number, you have unique. You have unique MAC address here. You never ever see anything with the same MAC address. And remember, it is a code. It's a burn-in address. It is a hard code in the ROM. That's why in the network interface card here. So with the same computer, you are sitting from here or go back home or whatever. So MAC address here always stay the same. But the IP address changeable. Right? You see, right? The same. Your name will always stay the same. But when you move the house, your IP address change. Okay, so that remember about this one. Now I think that's everything about the review. You know everything about the transport layer. You have the TCP, you have UDP, and you know everything about the connection oriented, and you have a connection link. You have the 3-way handshake. You have the two-way handshake when you terminate it. You know something about the sequence number, acknowledgement number. You have about the sliding window, right? And when you move to the internet layer, you have the IP about IP address. I have the ICMP and you have the ARP, right? And when you go to the data layer, you have to know about MAC address and the OVY here. And now I think that we should move to the new module here. Now, in the module 5, it's everything about cabling. That is the thing about the physical layer, right? So whenever you involve in the network communication, you always have to involve the physical layer. Physical layer is everything about the cable, right? Can be copper cable or can be optical cable, or it can be the wireless access also. Whatever. Whenever you want to do anything with the network communication, you have to involve about the physical here. And in that one, in the module here, you talk about the cabling. It can be optical cable or can be the copper cable here. Okay, now the first thing you have definition of the frequency, bandwidth, and throughput, and also I mentioned a little bit about output also. You have the definition output also. So frequency is a measure in the megahertz or gigahertz here, which indicates the number of times in the second that electrical signal can translate. You can think about the frequency is everything about fluctuation here, right? Now we move to the bandwidth. Bandwidth is the amount of data it can now that is very important here. Theoretically here, transmit during the given period of time. So think about the bandwidth you can think about. You talk about the fast internet here. Normally you talk about you have 1 megabit per second. So what is it? It measures in the amount of data. That means 100 megabit here. And over during the given period of time, 1 second here. Right? So that means for 1 second, this one can carry for 1 megabit per 1 megabit here. Right? So you can think about when you send from the source to destination here. So during 1 second, you can transmit for 100 megabit here. But remember this one, it's theoretically. Normally it's in the ideal number only. But actually you never ever reach to the bandwidth. Never ever reach to the bandwidth because you have many things that impact during the transmission when you send from the source to destination here. So remember this one is a theoretically, that is the ideal number, the maximum number. You can reach it to the 100, but actually you never ever reach it, this one. So in order to measure the actual number, the core is the definition of throughput here. Throughput is measure how much actually, you see the difference between them, right? Theoretically, and this one actually transmit during the given time here. So think about this one. I had the bandwidth of 100 megabit per second. But actually, when I send from my computer to another one, I only reach to about the 70 megabit per second. You can think about this one, it's a throughput. Okay, and now talk about the reason that why the throughput is actually I never reach to the bandwidth here. I can think about this one process here. I gave you the very example here, so we can think about you are here in the Bloomington, and now you want to go to the Indianapolis. Now you can think about you have a truck. You have a truck here. So the truck here you can carry for the 1,000 apple, right? You can think about this data here, right? You can the truck here you can carry for the 1,000 apple, and in order to deliver from Bloomington here to the Indianapolis, I have to take 1 hour to drive, right? At 1 hour here. So in the theoretically, I can carry for 1,000 apple for 1 hour, right? So we can think about the bandwidth here. Bandwidth here is 1,000 apple for 1 hour, 1 hour here. Now what happened here? In order to carry for 1,000 apple, I need some time to put the apple into my truck. So think about I need 15 minutes for this one. I need 15 minutes for this one. And okay, when I go to the Indiana, I have to take it out. Right? I need 15 minutes here. That's the first thing. Now, during the driving from Bloomington to the Indianapolis, I have some congestion. I have the congestion. I slow down my 30 minutes here. So what happened here? I am able to carry 1,000 apple from the Bloomington to Indianapolis. But now instead of 1 hour, I need 1 hour for driving. Now 30 minutes more, 15 here more, and 15 here more. So totally, I only able to do the 1,000 apple, but for 2 hours. Right? So actually, you can think about throughput here. Actually, for 1 hour, I'm able to do with a 500 apple. So we see this is a throughput here. So we think about the throughput because you need everything about the processing time. Right? Processing time. What is the processing time? That means you do the de-encapsulation. Encapsulation. Right? That is about loading and unloading here. Right? That encapsulation and de-encapsulation. And you have to do it about the processing, and you have the congestion also. Right? You have many things that impact to the performance of the network communication. That's why the bandwidth here it is theoretically, but this one is actual here. This one actual here. It makes sense. Okay. Now we have definition about the throughput also. Let's clear this one. Now, so remember that in the case of throughput, right? You have to do everything with that. So think about if you want to deliver from the source to destination here, you have to do this is the data, right? This is the data here. You want to deliver from the source to destination. But you remember that in order to deliver the data here, you have a long process of encapsulation. You have to put the header in the transport here. You have to put the header in the network here. And you have to put the header and the channel here in the data link. So see, in order to deliver the original data here, you need a long way with the header and the channel. So the good put here, they have definition, the good put here. Good put is the actual data. You need to use it only. So the good put will be the throughput minus header. When you minus header here. So think about the same. If you have the chuck here, right? You have the chuck here. It can carry for 1,000 apple, right? But think about this one is it's very kind of the fragile apple, right? So in order to deliver 1,000 here, you have to use the bubble wrap, right? You have to bubble wrap it to wrap the apple here. So instead of 1,000, now you're only able to carry for 700 only. You can think about here, bubble wrap, you can think about this kind of a header. In order to deliver the apple, you need to wrap it. It makes sense?
Yeah.
Okay. Okay, so you have the modulation. Is that if you want to send the data, actually you have to send everything 0 and 1, right? So we have you have some modulation here. How you convert the signal into 0 and 1? That is modulation. So in the case of the copper cable, you can use frequency here. In the case of copper cable, you can use the frequency. So in the case you have a higher fluctuation, you can tell that is a bit number 1. But you have a slower fluctuation, you can tell that is bit number 0 here. And in the case of the optical cable, when you have a light on, you have bit number 1. You have a light off, you have the bit number 0. That is modulation. How you convert the data into the physical layer and transmit it here. Okay, and of course you have, you see the difference between the bandwidth and the throughput here, right? Because of transmission flow. Not only the transmission flow, but along the way here, you have many things involved, right? So transmission flow, it is the first definition here is a noise. Sorry. The first definition here is a noise. It is undesirable. Remember the noise. What noise? Noise is undesirable here. Undesirable. You don't want it. Influence, that means degrading or distort the signal here. Now think about this one here. The noise is measured in the decibel. So think about this one here, right? So when you send from the source to destination here, when you send from the source to destination, so we think about you have the bit number 1 here. You have the bit number 1. You see the bit number 1. You can think about we have the voltage of 0.5 voltage here. You send it from the source direction here, right? So if along the way you have many things about the external interference here, you can think about you have the microwave, or you can have the elevator that distort here, the distort signal here, right? So think you want something is a perfect square here, but something if you got it from the external interference, it's not distort the signal to this one here. So when you receive the definition, it's very hard for you to tell this one is bit number 1 or this one bit number 0. Is that it degrading or distort the signal here? Right? Because you got it from the external interference here. So for the copper cable, normally you have the 2 types or have the 2 common source of noise, including the first one, electromagnetic interference. Anything that generates electromagnetic. I can see the light here, or elevator, or microwave, right? And by the motor, the power line, television, copier, right, the line. The second one type of the electromagnetic interference is that radio frequency. Everything about frequency here. You can think about microwave. So, right? That's the first one. That's the first source of the noise here. The second one, the crosstalk. The crosstalk. Yeah, the second one, the crosstalk. The crosstalk occurs when the signal on one wire that leaking out on the adjacent wire signal here. You can think about this one. If you look at this one, they are the UTP cable. You see, they put the wires next together. So see, when you put the wire next together here, you have the possibility that the signal here leaking out from this wire here, leaking out from this wire and impact to this wire here. And they call it the crosstalk. Crosstalk, that means when you put the 2 wires next together, adjacent together, you have problem with the crosstalk here. And it can be it's an alien crosstalk between the 2 cable, or near end crosstalk, or the far end crosstalk here. Okay, so see, when you put the next together, right, you can have the possibility of leaking out the signal from the one wire to the adjacent wire. That's why you have the crosstalk here. Okay, so now you have remember that noise. What is the noise? Noise undesirable. The first one, undesirable, and it can degrade or distort the signal here. And you have the 2 common source. You have electromagnetic, and you have the crosstalk here. Now, you have definition about attenuation also. You have attenuation is a lot of signal strength as it travel away from the source. The thing, right? The thing with you at the beginning, you are very strong, but if you run a long way, you exhaust the here. The same with this one here. The same with the signal here. At the beginning here, is a very strong guy. Perfect square here, but the long run is very degraded here. I see. Very hard for you to tell which 1 or 0 here. Or somehow here, at the beginning, you are the number 0 here. But you got it somehow, it's from top. Not this one. This one actually is external. I don't know. You can think about the attenuation is that you lost your strength when you run a long way here. That's why so for the specific cable, you only have a limit. You only have the limit on the length here. For the cable here, for the UTP cable, you cannot transmit it greater than 90 meters. Otherwise, the signal is totally degraded here. That's why you see for the UTP cable here, you cannot transmit it more than 90 meters. Okay. So if you want to make it up for that, you can use the repeater here. I see at the perfect square here. Somehow you distort it and degrade. And you can use the repeater to make it perfect square again. Now, that is the first definition. The second one is latency. The latency is the delay between the signal transmit and receive. You can think about here. In order to deliver from the source to destination here, normally it takes about 10 milliseconds. 10 milliseconds here. That is the latency. And remember that latency for some application is very sensitive to latency. You can think about voice over IP. Voice over IP here is very sensitive. So think about if you talk, but you have to wait a while until you receive the voice from the other end here. So the latency also very important here. And it depends on the what type traffic, what type of the transmission you will see. Can cause a transmission error here. The length of cable affects the latency, because the longer you run, the more time you need it here to run it here. Right? Okay, so we have the round trip time. Round trip time, that means you deliver and you receive it back here. Right? You have the round trip time here. So you can check latency or the round trip time by the ping message. You see, I have the ping message here. It tell you, yeah, how long, right? How long to go from the source to the destination. Okay, so I just want to use the ping here, right? I want to ping to google.com. Okay, so you see, when I ping to google.com, you see, I have a round trip time here. It take 9 milliseconds to reach from my computer to the google.com and come back. And also information about time to leave here. You see, TTL here. So when this number reaching to the 0, the packet will be dropping. So the ping message here, it belongs to the ICMP. You know that is a layer 3 protocol of the TCP/IP model here, ICMP. Or you have one more tool you can use. It's a chaser here. So in the case if you want, see in the case of ping, you can tell you that you are able to reach definition or not. Can tell you that this one here, you reach it. But if you want to do with the troubleshooting here, you want to know that from my computer to the Google, how long it take from the one, how many router involved, right? So we can, that's one we have to do the chaser here. And for this one, it tells you step by step. I see the first step is deliver to my default gateway here. 10.2.2.1, and the next one is 10 to send it to another one here. So see, in order to deliver from my message to the Google, I need to involve the 14 steps. It clearly tell me what are they. And the first step to the default gateway and go on. Right? So this one is very helpful in the case you do the troubleshooting here. Right? So we can see at what step my packet is stopped or what happened is that. Now we have the definition of the duplex, half duplex, and simplex. We have some definition of the duplex here. The first one, the full duplex. Full duplex, that means signal travel in both directions over medium at the same time. Right, so we see you have the sort here. Sorry. You have the sort and you have the definition here. At the one time, you can transmit it or you can receive it at the same time. They call it the full duplex here. The half duplex, you can transmit or receive it, or not and like this one and here, and this one or that means you can transmit or receive it, but not on the same time, not at the same time. And simplex is that you are able to transmit only one direction. Yeah, one direction only, or receiving only, right? One direction. Okay. So back then you have the some of the device, they work with the half duplex here. Half duplex, that means when the computer on the same network, say if someone transmitted, you cannot transmit at the same time. Otherwise, you have a collision here. And so back then you can think about when you work with the hub here. When you work the hub, what is this? Let me see. So when you work the hub, The hub is a one as a layer one device. The layer one. It looks like the switch. It looks like the switch, but it's a layer one device. And layer one device that we have no idea what is the MAC address. Right? So when you connect to the computer to the hub here, computer to the hub here. Right? So when this guy transmits to the hub send it out to everyone. How many send it out, right? So see, send it to this one and send it to that one here. So you see, when it sends this one here, if this one transmitting, you have to receive it. You have to listen. You have no way to transmit at the same time, otherwise you have to collision. But normally nowadays every device they work is a full duplex here, so you don't have to worry about much about the half duplex. But back then in the legacy, you use the bus topology or you use the hub device, and you are able to transmit or receive it, but not on the same time. And simplex you can see in the case of the in the case of fiber optic. So in the case of fiber optic, you only have the two wire next together, one wire for transmitting and one wire for receiving. Yeah. Yes, two line. Yes, yes. So yeah, you can set you can set the hub duplex, or you can set the speed also in the network interface card here. You can go and you can set with you go to the device manager and you can go to the network interface card and you can change. But normally no one touch it, right? Because it's automatically working with the full duplex now. Okay, now we have some definition about full duplex, half duplex, and simplex. Now we have the multiplexing here. Multiplexing is a form of transmission that allows the multiple signals to travel simultaneously over the one medium. So you can think about this one, right? You can think about you think about your home computer, right? You have the home computer here. Sorry, the home network. The home network you have router here. So in the home network, you can have more than one computer, right? You can have the desktop, or you can have the laptop, or you can have the cell phone here. Right? So see, but all of you only have one physical cable to connect to the internet. Right? So in that case, in order to make sure that everything works smoothly, you have to work with the multiplexing. Multiplexing that you that interleaving them together. Right? So see, you can break it down here. Number one, number two, number three, right? And this one also, I break it down. Number one, number two, number three, right? And this one here, I break it down. Number one, number two, number three, right? So now, in order to deliver them at the same time, right? In order that they are all able to work at the same time, you have to interleaving them together. You have to interleaving them together, right? So for this one here, I put number one for this one, right? Now, I take the number one for this one here, right? I take the number one for this one. Now, I take the number one for this one, and so on. Right? That breaks them into the segment and interleaving them together. So everyone at the same time, you are able to communicate together. You are able to go to the internet here. Right? Make sense? Huh?
Yeah.
Now, if you don't work with at segmentation, if you don't work as a multiplexing, right? So at one time, you only have one computer communicate to internet only, because you only have one single connection here, right? Right? So in order to do it, to make sure that everyone here able to go to internet, you have to break it down in the segment and you interleaving them together. Right? So in that case, you have the sum type of the multiplexing here. The first one is the time division. Time division, that means you break it down into the time slot here. One slot here. Slot number one, work with the computer one. Slot number two, work with the computer two. And slot number three, work with computer three, and so on. 1, 2, 3, and again and again. That is slot here. It's a time division. You can have the frequency also, so you can break it down into the frequency. So if you have the high band, you can work with the one computer, and lower band, you work with the another computer. Okay, so In the case of the optical cable, they that use the wavelength division multiplexing, because in the case of the optical cable, they work with the wavelength here. Wavelength is the optical cable, so you can multiplexing them together by the wavelength division multiplexing here. Okay, now we talk about the coaxial cable and twinaxial cable. That is the most common cable you can see at the home internet. You see, you have back then they work with television cable, but now you can work with the internet cable here. The core is coax here. The core is coax. You have the central metal core. This one here. This one is actually the one who carries the signal. But in order to do it, you see, you have many other layers to protect the core signal here, right? The thing is that you also have some kind of the foil here or sealing here to protect it from the external interference. I see if you have something about external here, it can protect you from the external interference, right? And this one is to protect you from physical damage here. And you have some of the, you have the two types. You have RG6 or RG59 here. You can terminate this one here. You have this one here. You can terminate it by treat it to the terminator here. So we can have the app connector or BNC connector here. Okay, so this one, what is it? Okay, this one is a twinaxial cable. I'm not really sure, I'm familiar with this one. Honestly, I'm not really, I never worked with this one. But as that here is the definition, so you can look it up to see what's going with this one. Now, this is the most common one. You can see in the internet here, right? That is the most common one here. In the internet network. The core it is a switch pair cable. The switch pair cable is called, you have the 4 pair. You have 4 pair. Yeah, so see, you have 4 pair here. You have 1, 2, and 3, and 4. I have the 4 pair. The switch pair cable consists of the color code. You see, each of the wire it has specific color here. Specific color here, right? So we can have you have the white, orange, and orange. You have the white, green, and green. You have the white, blue, and blue, and I have white, brown, and brown here. You have the 4 pair, and there are 4 pair here. And it is color and insulate copper wire with 0.4 to 0.8 millimeter here. And every 2 wire are treated together to form a pair in scale of plastic sheet here. That's why they call it a treat. They call it a treat here. Sorry. That's why they call it a treat here. Treat here, that means you see, each of the why they treat together. And the reason that they treat together because they want to canceling out. Yes, sorry. So canceling crosstalk. So we know that crosstalk that means when you put next together, right? You can have the high chance of breaking out here. So when you two together here, you see, when you two together, you see, 3 together here. One Y you have the positive, and one Y have negative. That is canceling out about the crosstalk here. That's why the reason that they call it a treat pair, because you always treat it together in order to canceling out crosstalk here, right? And you have the 4Y, but you use 1 pair to send data and 1 pair to the receive data here. Okay, so for the fast internet, actually you only need the 4Y only, but for the gigabit internet, you use you fast internet you only need two pair, but for the gigabit internet you use the 4 pair here. And you have the most common treat pair you have the Cat3, Cat5, Cat5e, Cat6, Cat6a, and 7, 7a, and 8 here. And Cat5e or higher used in the modern local area network. So for the Cat5, you can transmit with the fast Ethernet. You have 100 megabit per second here. And the 5e, you can go up to the 1 gigabit per second. And for 6 here, you can go to the 1 gigabit, and 6 here, you can go to the 10 gigabit per second. So, okay. So remember one thing about this one. They call it the tweet pair because you have to treat them together. And the rate of the tweet is not the same. Some is a higher rate and some is a lower rate. You see, someone is a rate here, high rate, but someone is a longer rate here. It's not always the same. Okay. And in the tweet cable here, again, they break it down into two categories. They break it down into two categories. The first one is the ATP, and the second one is UDP here. UDP is the most common one used. The most common one used. But you see, that is a copper cable, so it had a lot impact from the external interference about the EMI here. That electromagnetic interference. You can think about you have the electro light, or you have the microwave or elevator. Right? So normally in the normal situation here, you can use the UTP, bright chip, and easy for you for the installation here. But when you work in the environment, you have a lot of external interference. You can think about if you work in the manufacturer environment here. Right? So in that case, you have to work with the ATP. The ATP is that we have the UDP, but you have the outer foil. You have outer foil for the cable and outer foil for each of the pair here. It's help you to protect it from the internal interference here. Okay, so that is a shield. So normally you use the UTP only, but in the case that you work in the manufacturing environment, you have a lot of external interference. You have to work with the ATP here. You have to work with the ATP. It's individually insulated and may come surrounded by the metallic substance, a shield, or they call it the foil here. The foil or the shielding at the barrier to prevent from external electromagnetic force here. Okay. Remember, the way it works the same. The UTP and ATP, the way it works the same. The only thing is that it can work with the ATP is that help you to protect from the external interference here. Okay, so we see instead of using the UTP, now you use the ATP here. You see, for each of a pair, you have the foil outside it, and outside also you have the braid copper shielding also. So have a lot in the protecting in the way of protect from the external interference here. Okay, so you see you have the foil for outside foil for each of the pair also. Okay, now the UTP is the most common one. The most common one is, see, you have the UTP here, and you can have you have UTP. It not contain the additional shielding. It not have anything with the shielding here. Sorry. Less expensive. It's less expensive and less resistant to noise than ATP because you don't have the foil here. You don't have the shielding to protect it from the external interference here. This one more popular. It's more popular because it's cheaper and easy to install. Easy to install here. Okay, so now we can compare the ATP and UTP. So when you compare the UTP and the ATP, from the throughput point of view, totally the same. The way it works, yeah, always the same rate. The same rate. The cost, this one here, expensive, right? Because you need to the shielding, the foil here, and expensive here. Connector the same. The connector you connect with the RJ45 here. RJ45 connector here. And you have the noise immunity. This one is more noise resistant, right? You know that. And the size and scalability, the maximum segment length for the board is 100 meter. You cannot transmit it more than. Otherwise, you know the definition of attenuation here, right? The longer you run, the weaker you are here. Okay, so some category of the ATP require shorter segment length to achieve the maximum throughput. But basically, you cannot transmit more than 100 meter here. And remember, from the performance point of view, ATP and UDP for the throughput, it's always the same. The only thing is that it can protect it from the external interference. That's why it's more expensive and it's harder for you to install the cable and terminate to the RJ45. Okay, now we move to the cable P now. So we see that in the case of the cable, right? You have the 4 pair and they are specific color here. And the reason that is they use a specific color because you have to follow the pin now location when you terminate into RJ45. Sorry, yeah, RJ45 terminator here. And they have the 2 standard. They have 2 standard to terminate to the RJ45 plug. The first one is 568A and the second one is the 568B here. They have the 2 standard. And the difference between them is because of the pin location away, the pin location here. So you can see in the wire connection here, that is standard A here. So in the standard A, you have white, green, and green. You have the white, orange. You have the blue, white, blue. You have the orange. You have white, or sorry, you have white, brown, and brown here. That is the pin location when you work with the A. And for the B, you see that is the location not the same. So it totally depends on you. It depends on the company policy here. If you work with the A, you follow the A. If you work with the B, you follow the B. But remember, you only have the consistent here. So if the computer work with A, every computer have to follow the A standard. You cannot have one computer A and other one B here. So if you follow the standard B here, everyone have to work with the B here. So you can see how we terminate it here based on color here. How we terminate here based on color. Okay, so I think we have a watch video here. Okay, so what is it? Okay, so in the case of the pin out here, mostly we use in the case of the straight through cable here. Straight through cable, that means both end here you have to follow A or B. Right? So that is the terminate in B, this one B. Or this one A, this one A. They call it straight through. Straight through, that means both of the end you have to follow the same standard here. You can A here, or it can B have to B here. Right? And they have the rollover cable. Rollover cable, it is a console cable when you work with the configuration. When you work with the configuration for the network, for the router or the switch here. But for this class, we don't do anything with the lab. That's why I don't want to go into detail for this one. But actually for the rollover, you totally flip it here. One connect to the 8, right? 2 connect to the 7, and so on. And some of the device, they have the power over Ethernet. That means you see you have the cable here, but also deliver the power to some of the device. So think about, you have some of the camera, you don't need the power cable, separate power cable, but it can deliver the power on the Ethernet here. See, you have the sum here, right? So basically, you need, think about this one here. Basically, you need the separate power cable. You plug in that, but now with the power over Ethernet here, see Ethernet here, it can deliver both the data and the power. So you don't need a separate cable for the power here. What is it? Okay. So I think that you now should watch the video here, see how to terminate.
You want to be an IT pro, so you must have all of these tools.
You can see this is a lot different. We still have. Hi, my name is Kane, and I'm here to help you. On my network, and they're like, easy. We're gonna need a Category 5E or Cat 5E patch cable. So we're gonna have a length of cable that we've selected. We've got one about 10 feet right here, and we're gonna need 2 modular plugs, RJ45. We also have our Cat 6, which we also have about 10 feet of cable here, and we have a Category 6 modular plug. Also, you're going to need an RJ45 crimping tool. These things you can pick up at your local hardware store, Home Depot, Lowe's, that kind of thing. You can find them online. They're...
On this slide, we also have the tool here, and if you want to practice, you can do it. You have the crimping tool, you have the power cable cut here, and you have this one is to test for the continuity of the cable, to make sure that the pin here is located correctly or not. Yeah, so this class not required to do, but if you work with the class NETI 105 or the Cisco class, you are required to do it.
Relatively inexpensive, and you can use these to make hundreds of cables. This one's 300 years old. People will always ask you what's the difference between Cat 5e and Cat 6. And first and foremost, Cat 6 is a bigger cable. It is a higher standard of cable. It is able to shoot gigabit networks down with a lot less crosstalk, which is the noise that is made with the electricity running over the wires talking to each other, and it creates it slows down your network if you got too much crosstalk. So Cat 5e will be good for gigabit. Cat 6 is just better for gigabit networks. If you find Cat 5 cable, which does not have the E, it will not work for gigabit networks at all. Just don't try it. It's not cool. You'll be like, why is my network so slow? It's because you're not using good enough cable. Also, if you're doing this out of your home, Cat 6 is expensive by comparison to Cat 5e. We're talking like 30 cents a foot versus Cat 5e, which is probably like 15, 16. I haven't looked at the prices recently, but it's expensive to get Cat 6. So unless you really need the higher standard cable, get Cat 5e, it'll do just fine. So we want to scar the cable sheath so we can break away the sheath and expose our conductors on the inside. So we're going to use it just very gentle. We're going to scar the cable sheath with the cable wire, or with the cutter there. And now we're just going to bend the cable, and you can see the real stress here. You can bend it, and you can put some stress on it, and it'll break away. Alright. Get the sheath exposed. And once we're here, we want to separate out our pairs. And you'll notice this little string here. This is actually for pulling back and exposing more of the cable. So you pull this back down this way, and it'll just cut the cable down. I'm not going to do it because I don't need any more than this. But you can just very carefully clip that string away. Here I've untwisted all of our conductors into our different color codes. We've got our orange pair, our brown pair, a green pair, and the blue pair. We want them to be in this order I'm going to give you right now. It's going to be white with the orange stripe, orange. And then it's going to be white with the green stripe.
This guy here is he follows standard B. That's standard. Remember that you have the 2 standard A or B. Depend on the location of it. So this one we follow the standard B.
Solid blue, white with the blue stripe, solid green, white with the brown stripe, solid brown. The next thing we want to do is we want to cut back the conductors to the proper length so they will fit nicely with our modular plug. There's a crimp on the inside of the plug that will be pushed down when you crimp it with the crimping tool. It's a lot of crimping. You want the sheath to be extended past this little space here, so it will get crimped down and it will hold your cable in place. Okay, so these conductors have to come all the way up to the end of the mod plug, and we want this blue sheath to come extend past the crimping space that's right here. So we're going to measure about where we want it, and we figure this length is good. And we want to cut, but we don't want to cut at an angle, we want to cut as straight across as possible. That's why we use these wire cutters. They explode everywhere. Now you can see a little bit of deviations, but it's going to be okay because it'll it'll flush up in the end of the conductor. Next, we're going to very carefully, and you want to, at this point, just double check your wires, make sure that they're again in the correct order. That's white, orange, orange, white, green, blue, green, white, brown, brown. And you're going to be very careful. You want to set them inside, and I don't know if you can see it. The wires are actually being separated out inside the plug along little tracks. And they'll go all the way. Push it as far up as you can. Give it a little push. The sleeve will go up further. That's probably a good thing. You can check the end, and you'll see the copper conductors right along the end. That'll be nice and shiny. Okay, so now we're going to go ahead and crimp the cable down. You want to make sure that you don't wiggle this too much once it's in place. And you're going to slot the mod plug into the RJ45 connector on the crimping tool. Again, check the other side of the cable. Make sure you see all the copper conductors. And I usually do this 2 or 3 times. You'll see here with this push down onto the cable. It's a nice solid connection. These wires get crimped down and it pierces the sheath. This is where you can see the copper conductors are flush with the end of the connector. That's how you know you're going to have a nice, good, solid connection. Alright, now we're going to do this with a Cat 6 cable. The procedure is more or less the same. There's subtle differences. The things that make this cable better are also what make it harder to work with and easier to work with at the same time, and I'll explain it as I go along. The sheath is a little thicker because it's a bigger cable, and it's going to be easier to score and break open. So let's... Look at that. Came clean apart. There you go. Now, you can see this is a lot different. We still have the string for tearing back the sheath. We don't need it. Careful not to cut any of your wires. Now, Cat 6 cable has got a larger conductor. This is a 22 gauge wire, where the Cat 5e is a 24 gauge wire. Which means that this, for all of you Europeans, this is big.
So basically, that is the way terminated by the same. That you always have to follow standard here. You have to always follow standard in the pin termination here. You can be follow on the A or B standard. It's up to you. Okay, and remember that for the UTP or ATP, they break it down. They call it the CAT here. CAT that in category. The CAT that in category. So basically, for the local, for the Ethernet network, you have to go with the CAT. You can have the CAT 5, CAT 5e, 6 or 6e, and nowadays you can go to the 7, 8 here. So remember that for the 5 here, it only support for 5 Ethernet. That means the 1 megabit per second. Sorry, 100 megabit per second. But for the 5e, it can support to the 1 gigabit per second. And for the 6e, it can support for the 10 gigabit per second. Okay. What do you think for this one?
It's A, right? 10 meters.
What do you think? What's the maximum length of Ethernet network it is?
Is it A?
100.
Right? 100.
Is it 100?
Yes, it's 100. I think I mentioned it somewhere. So I mentioned that is the 90 meter or the 100, right? You know that you have definition of the what is it?
Also in chapter 2, they mentioned.
You have a definition of attenuation, right? The attenuation, that means that at the beginning you are a very strong guy here, but the longer you run, you are degraded here somehow, right? So the maximum denominator is the 90 meter or 100. 90 meter, that means sometimes you include the patch cable, small, also, So you can think about this one 100 and 100 here. Now, so you mentioned about optical cable. In the optical cable, you can have a coaxial cable. You can have a coaxial cable, or you can have UTP cable and ATP cable. And remember that UTP is the most common one you see here. And if you work in the environment that you have a lot of the external interference, you have to work with ATP. The only difference between the ATP and ATP is that ATP has to protect you from the external interference here, right? And when you terminate it, you have to follow the standard 568A or 568B. And the difference is based on the location of the pin away. Now we move to the fiber optical cable. Fiber optical cable, or sometimes it's called fiber, contain one or more glass or plastic fiber. At its center, they call it the core here, the core. The core here. The data transmit via the line here. The light, the pulse of light sent from the laser or light emitting diode here through the center fiber. And surrounding fiber is a layer of glass or plastic cone. They call it the cladding here. So basically, you see, you have one is a core here. This one the core. And outside of that, the core is a cladding here. The cladding. And the way you transmit is that you have the ray of light here. It always reflected, right? It's always reflected inside the core. So it reach from the source to destination, and they have the. If you understand this one, I don't know what is the name in the kind of physical name here, but they have this one. They have the higher index here, and this one they have lower index. That's why you have the reflection here. Okay, thank you. That's why you have the reflection with this one. So see, when you have the ray light here coming in, it always contains inside the core only. So you have the reflect here, and of course, if you have the higher angle here, right? If you have a higher angle, it can leak down from the core here. Okay, so this is one case of the UTP cable testing here, and you can see how that when you terminate it, when you terminate the cable, you can check if you terminate it correctly or not. So you can plug it in the two end here. So you can see they matching, right? Pin number 1, pin number 2, they all matching together. Now, this one work perfectly, right?
It's a loop.
Yeah, it doesn't work perfectly. Matching, but somehow when you terminate it, it's not correct. Show you. Show you. That's why you can. This one is a tool when you use to test the cable here. When you terminate and okay, yes, that is the name here. The cladding is less dense than the glass or plastic in the core here. That's why it reflects the light. You can think about when we have the surface of the water here, right? You have the water here, and you have the light, right? You point down, and you have the reflection on this one here, right? If you have a reflection here, that's the same as this one here. Okay, so that is the optical cable. You see, in the core here, that is the one who carries the signal here. It's very tiny, very thin. It's thin kind of the hair, my hair here, right? You see, and very easy to bend it. That's very small here.
The glass?
Yeah, that is glass. Inside the glass. Yeah. So you can break it if you overbend it. Yeah, it is glass. It's a glass here. Yeah, it has the glass light. So when you have the light on, you have to reflect it totally inside, contained in the chip here. Okay, so that is a fiber optical cable, and the reason that it is a fiber optical cable because it offers some of the benefit over the copper cable. The first one is extremely high throughput. It can go up to 10 gigabit per second here. It can go up to 10 gigabit per second, or more than that. The second one is a very high noise resistance. It's not totally immune to the external interference by the electromagnetic interference here, because it's nothing to do with electromagnetic. It works with the light here. So it's totally immune to the electromagnetic interference here. That's why it is very high noise resistance here. Excellent security. It's very hard for you to tap, to hijack the communication here, and able to carry the signal for a longer distance. So remember, for the UTP or ITP, you cannot go greater than 100 meter here, right? But when you work with a single mode in the optical cable, you can transmit it up to the 100 kilometer here. Yeah, of course, you have drawback. It's more expensive, right? Than try to repair here, and it requires special equipment to slide. So when you interconnect them together, you need to supply it here. So it requires special equipment here, and of course, we see the source of the light. It can be the laser. It's very dangerous here. That's why you have the high attention when you work with the optical cable. So in the optical cable, they break it down into two modes. They break it down into modes. The first one is single mode, and the second one is a multi-mode. The first one is single mode, and the second one has the multi-mode here. Now, in the case of the single mode, here, very narrow core, very narrow here. Narrow core here, it has the 8 to 10 micron in the diameter here. You have 9 to 10 micron in the diameter here. And the light source they use the laser here, the laser here, then the light travel over one part, reflecting very little. So you can think about in the case of a single mode here, you can think about you only have one ray of light. You only have one ray of light here. And the ray of light here, it comes from the source, the radiation here, and very, very little reflecting away. So you see, you don't have many ray of light. That's why you only have one ray of light, and it's very little reflecting here. That's why it can go over long way here. Can go over long way here. And the light doesn't have the disperse at the signal travel here. I'll talk about what the dispersion later when we work with the multi-mode here and why we have to care about the dispersion here. Okay. And single mode here can carry signal many miles before you need to repeat it. You remember that in the case you transmit it here, right? So you have a long way to be created. The repeater, that means you regenerate it to the original data here. So for the single mode here, you can carry the signal many miles before repeating it required. Normally, you can transmit up to the 100 kilometer before you need to use the repeater here. And it's rarely used for the shorter connection due to the high cost. It's expensive. It's more expensive than multi-mode here. It's more expensive here. So normally it is long for the long haul communication here. Long distance here, or can you see that it from the intercontinental submarine cable here, right? And the internet backbone depend on the single mode fiber optical here. So remember that for in the case of the single mode, you have the laser at the light source, and normally you only have one ray of light. You have one ray, and very, very little reflection only. Now in the single mode here, the core is different. You see, this one is only 8 to 10 here. See, 8 to 10. But in the multi-mode here, the core is bigger. You have the 50 to the 62.5 micron here. And the laser, sorry, the short line here, you can use the laser or light emitting diode here to generate light, travel a different angle here. That is different. You see that in the case of the single here, in the case of single, you only have one ray of light along the way, right? Along the way, you have one ray of light. But in the case of multi-mode here, you see, you have many rays of light. And they come, what is it? They come at, what is it? Different angle here. You see? See, this one here now, if you look at this one here goes straight forward, right? So see, he reaches here already, right? But this one here, reflect here. This one already come here. So see, the difference between the, so think about, you transmit the bit number 0 here for the straight one and bit number 1 here, right? You see, bit number 0 here already, but bit number 1 is long way from bit number 0. They call that one is a dispersion here, dispersion. So the longer dispersion, the high problem of the distortion the signal. Because you see, they're not on the same time, right? They're not coming at the same time here. They call it the dispersion here. That's why in the case of multi-mode here, you cannot transmit it for a long distance here. You cannot transmit it a long distance here. Otherwise, you have problem of synchronization here. I see bit number 1 here, but bit number 0, sorry, bit number 0 here, but bit number 1 here. You have a long way for the synchronization here. That's why for the mode here, you cannot transmit a long distance. Normally, you cannot transmit more than 2 kilometers. You cannot do it more than 2 kilometers for this one. Okay, and normally it used in the local network. It can connect between the router and the switch on the same data room, same data center here, and server backbone of the network, or you can connect the desktop workstation to the network here. Okay, and you have the many types. The fiber connector, the multi-mode connector can be classified by the number of fiber they connect, and the single mode can classify by the size and the shape here. So one problem when you work with the terminating here, or they call it the sliding here, that the shape and the polish used by the single mode for reduce back reflection includes the following. The first one, on-chip polish connector. The second one, the angle polish connector here. So in the case here, this one they call it on-chip polish connector here. You can see what's the problem here. In the case of on-chip polish connector, you see when you matching together and you put them together, right? So we see you have the problem of somehow you have the reflection here. Right? When you see when you have reflection here, so this guy here come and this one reflect here, totally canceling out the or not totally, but somehow canceling out the signal strength here. But in the case of angle here, you see you have the angle here. So when you come, it reflected here, not on the same rate, right? It's not on the same rate, so it have a lot in improve a program of the canceling out the signal. Okay, so for the fiber connector, you have many types of the fiber connector here. You have the LC connector, you have SC connector, or have NETI. You have many connector with the optical cable here. But remember one thing, that whenever you see the connector, normally you have to see 2 wire together because they work is simplex here. So that's why you have 1 wire in the transmitter and 1 wire receiving here. Okay, and you have the media converter also. Media converter is the hardware that enables the network or segment running on different media to interconnect and exchange signal. So we think about you have the network, you have both with the copper cable and optical cable. In that case, you have to convert it. You have the media converter here. Okay, so now you see they all work in pair. Right? You see they all work in pair here. 1 transmitter and 1 receiver here. I don't want to go into detail for this one because it's too technical for this class here. You just need to sum up idea what is a single mode and what is a multi-mode here. You have the fiber receiver. So think about this one when you terminate in the switch or router. You can plug in and plug out. They call it transceiver. Transceiver, that means it's very flexible. You have the slot. In that slot, you can have the copper cable or optical cable. And if you want to upgrade it, you just buy the transceiver and you plug in. Okay, so for the Ethernet standard for the fiber optical cable, you have the sum of standard. You have a 100 base XS here, you have a 100 base FX, and so on here. And it depends, right? It depends on the normally for the it depends on the wavelength also. You have a wavelength, you have the window of the 850 nanometer wavelength, or you have the 1310 nanometer light here. Okay, now you have the common fiber cable problem. The first one is a fiber type mismatch. It's actually more of a fiber core mismatch here. Even the same mode cable can be mismatched if the core have the different width here. You can think about this one here, right? So it's very tiny. It's very tiny here. You know that in the core, in the single mode here, the core of the single mode you have only from 8 to 10 micron, right? So think about this when you slide them together here. When you slide them together, you have the high possibility that they are not the same width here. Right? So in the case not the same width here. So when the light comes on this one, totally lost. It's not going on this one here. That's a problem when you slide them together here. You have the mismatch in the core that have different width here. That is a most common problem when you work with the fiber cable here, when you slide them together here. And also you have the wavelength mismatch when transmission are optimized for one type cable, but not for the second one also. Dirty connector, right? You see, when you work with the cable here, you totally rely on reflection of the light, right? So we see when you slide them together, right? When you slide one cable here and you have the other cable here, but somehow you have the dirty here. Right? So in the case dirty here, the light is totally transmitted to this one or reflected here. That is the most common problem here. So normally when you terminate the cable here, you always have to check for the dirty. You have the device to clean it, to polish it before you terminate it. You have the link loss, the power of the light signal emits at the one end and connection is subject to many loss along the way. From the distance, along the distance, of course, the lot you have, right? The higher loss you have. Or when you multiplexing together, or from the connection itself, whenever you terminate it, or patch it, or splice it, you have the problem loss here. Okay, so you have some of the cable troubleshooting tool. I can start troubleshooting the network connection problem by checking the network connection last stated indicator. So whenever you plug in the cable, you only have the light, right? You see if you have the green light, it's a work. If you have the blinking light, a green light here, it's activity. But whenever you see something red or amber light, it's something problem with the terminator here. If a cabling issue is suspected, you need to know which tool are designed and analyze the isolate problem here. Now you have the toner and the probe kit here. So think about in the case that you have, think about in the case here. This one is shown here. So see, is that you have a complaint from the one of the employees that he are not able to connect to the internet. So here's a one socket here, one socket here. So actually you see from the one socket here, you have to terminate from one socket. You have to go to the data center, and in the data center you have 100 of cable here running down, right? You have the 100 of cable running down here, and you don't know which one is it. So in that case, you use the toner and probe here. It's very helpful. So you have one end is a tone generator, and you come to the data center, you come to the patch panel, you have the tone locator here. So when you point out to the cable here, it generates the tone. You know that and cable connect to the one socket here. I think that you should watch the video to see how it works with this one.
We gotta tell people that Liberty Mutual customizes car insurance, so you only pay for what you need. And we gotta do it fast.
Woo! New personal record, Limu!
Only pay for what you need.
Liberty, 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 liberty.
Hi, this is Bess with CableSupply.com, and today I'm going to tell you about our tone and probe test set. Now let me demonstrate how to use the tone and probe test set. This is the tone generator, and this is the probe. This also comes with a nice carrying pouch for your belt, Very handy. It also comes with two 9-volt batteries. This tool is necessary to have when you need to identify a bundle of cables. Let me first demonstrate the tone. On top of the tone generator, there's a switch, tone, off, and continuity. And when I push it on tone, you'll be able to hear the tone with the probe. Plus, it has a continuity button. When I touch the ends together, you will see the light come on, which will identify that it has continuity. The nice thing about it is it also has an RJ11 plug. This also works with an RJ45. If you're running a lot of cables, you can plug it in and later identify them with your tone and probe. For identifying cables, you want to turn on the tone. Before you plug it into a jack, you need to make sure everything is working. And the way you do that is to test it first with the probe. You'll be able to hear the tone with the probe. Now that I've verified that the system is working, I'm going to plug the mod plug into the jack on the wall. This is the jack that I want to identify at the backboard. All you need to do is plug the mod plug into the jack that you want to identify. Make sure that the tone generator is set to tone. Now go to where your cables are located in the other part of the building. Here we are at the backboard in the wiring closet. Make sure that your probe is turned on and the volume is up.
In the data center, you have the bundle cable, right? Many of them, so you don't know which one is connected to the right, the one's connected here. That's why the tone here and probe here is very high.
I'm going to hold down the blue button and run the probe over the punch down cables at the 66 block. There it is. Now we have successfully identified which cable goes to the jack in the other room. That one. You can also use this to identify ports in a patch panel. You can also use the probe to identify which cable in a bundle has the tone on it. That's the one. As you can see, you can identify which cable in a bundle goes to that particular jack. Thank you for watching our video.
And so it's very helpful in the case you want to do the troubleshooting. You have a bundle cable, you don't know which one. And this one here, multimeter or cable continuity testing. That's the one I show you. Right? So we can see, you can check and test exactly they connected. So when you terminate the cable, it connect to the correct pin or not. That one is the cable testing continuity. And some of in the case of the optical cable here, you have the OTDR. You have OTDR. Here, I show them here. Yeah. It's very helpful in the case you work with the optical cable here. The optical cable, you know that normally you work in the underground, right? You work in the underground for the long distance. You have to work underground, and you see somehow we have the construction somehow. Yeah, you break the cable here. Now, so we think about in the case of the optical cable, right? You think about we have the in the case you have this. Let me share it here. In the case of optical cable here, you have the source and have that here. That you have the optical cable is underground, right? So see, you have the You have the conjunction and somehow break it down here. The hardest thing is that you have to locate the location. Huh? You want to slide it together, you have to locate it here. So in that case, you use the OTDR here. OTDR, optical cable reflection device, whatever, reflection device. So when you plug in the OTDR for this one here, it measure here. It will plug measure here, measure. When you have the breakpoint here, right? You have the reflection. Right? Whenever you have a breakpoint, you have reflection, and it come back to you. So from the OTDR here, you can identify that I need take about 10 milliseconds for the reflection, right? So in the case 10 milliseconds here, you can figure out what is the distance here from this guy to this guy here, right? So think about, you figure out that about the 2 kilometers, and you can narrow down the location, right? You can see what is going on with this one. So I think that's all for the lecture for today. Any question from you? Let me know.
No questions, no.
No questions. So let's see what you have for the homework here. Okay, so this one is very simple. This one is you have the tool to measure what is the throughput in the computer. So actually, you can download it from the computer, and so they call it a speed test. Yeah, so you can run it online. You can see right now I'm about 67, 68 megabits per second. Not bad. And for this one, you do the same. You go to the simulation, you do the speed test the same here. It's not a problem for this one. Now, this one here. This one, the Wireshark. I want to do the Wireshark on you. So in the case, you have to go to the capstone project by what? Okay, capstone project by what? Project by what? Because the TCP segment in Wireshark capture here. So DNS, I had to work with the Chrome. This one I had to work with Chrome. So I just clear the net here. Net internal. Okay, now what is DNet? That want to review what is DNet? Do you remember? And why do we need to use DNet? What is the purpose of DNet? Huh? Hello? What is the DNet here?
To find domain names.
Okay, so here's the thing here. DNS is domain name service, service or system.
Oh, my.
Okay, now the thing is that think about if you want to go to web, whenever you go to the web browser, right? If you think about you want to go to the, so you enter the World Wide Web here and you go to the google.com or cisco.com here, right? So see, actually, in order to go to the google.com or cisco.com, the computer have to know what is the IP address of google.com, what is the IP address of cisco.com. Right? Think about you have 170.10.10.10 here, right? But here's the thing, you are easier to remember cisco.com than the number here, right? That's why normally you work with the URL here, URL, universal relocator location, resource location here. URL, everything about the one-way web address here. I see, instead of remember about the IP address, you remember the cisco.com, make more sense, right? But you see that for every communication ultimately, you have to work with the IP address here. That's why the DNet here, you have to use the DNet. DNet is matching between the one wide web address and the IP address here, and the IP address. I also think about if matching here, I'll tell you that if you go to the cisco.com, you have to go to the 170.10.10.10 here. Huh? So for every computer, the first thing you have the local DNS cache here. You always have the local DNS cache. The first thing that when you go to cisco.com, it look it up in the local cache. And if you only have the matching between cisco.com and the IP address, it's then route it to the cisco.com directly. Right? And if in the case that the local cache here, you don't have it, you have to query it. You have to query it and you have to route it to the DNS server here. You have to route it to DNS server. DNS server for every computer. That's why every computer you have information about DNS server. Right? So you query to the DNS server. You raise the question here. What is the IP address of the World Wide Web cisco.com? Huh? And this guy here, he have the big database matching between the World Wide Web and the IP address here. And he return it to you that you have to go to the 170.10.10.10. Right? So after that, you can route it to the cisco.com here. So for this one here, for this homework, the first thing you have to clear it. You have to clear the DNS cache here in the browser, and also you have to clear it from the computer here. This one is the same when you have. Okay, so now if you want to clear from the if you want to clear from the local cache, right? We have the command here. See IP config plus here. Okay, you already plug it, right? So this yeah, now you don't have anything, right? You see, you don't have anything here. So now what happened? Now we go to this one here. Now I have to start the Wireshark first. You go to start catcher, and I go to the NASA.com. Why not able to copy it? So now I just stop it. I just stop. Okay, so now I already capture. I can capture everything as I go to here. So now I can do by the analyze from here. You go to this one. Now you can filter, right? You can filter on the DNet here to see which one works with DNet. Right? So I filter by put the DNet here. You see, it query here, right? Because I clear everything in my cache, right? I don't have anything in my cache here. That's why if I want to go to the nasa.gov here, the first thing I have to query to my DNS server, and you can check it here. You can click the IP number. You can see it here, right? In my computer, my IP address here, 142. My default gateway router here, and I have DNS server here. I have 10. Sorry, yeah, this one. Sorry, 10.2.8.10 here. That's why it query to the 10.2.8.10. Because it root to, right? So see, I query it here. I can click it here. That is my IP address. That is the IP address of the DNS server. And in the case this one here, you have the port here. You have the port 53. That means you have the DNS query here. And you see, when you break it down for the query here, you have standard query. See the black here. You have the recursive query here, and you have the question here, response here. In the question here, you have the response for this one. So it's responding. If this one is the title here. That is a query. So what you have to respond here? You can click on this one. Respond here. You can click on this one. It tell you, right? So it tell you here. If you want to go to the NASA.gov, you have to go to the 23.22.90. Sorry, .39 and .130. So that is the way it works. You send the query, and you have to respond here. Query and respond here. Query and respond. Very straightforward here. So I'll come back to this one. What else? It's very straightforward. This one, standard query. Okay, now this one I will tell you, right? That I will tell you what is a UI sort of the network interface card. So if you look on this one, if everything here is this one here, the definition and the sort, that it is the MAC address of your computer, right? And the first 6 hexadecimal digit here, it is a UI, right? So you can check it at 872.EA here, or you can see the same, my physical address here, this one. Sorry. If you want to check, you have to check from this one. That is sort here, right? So that's why I have the 70B5E8 here. And you can come back to the question here. What is OUI? What is the OUI of source NIC here? And that is my answer here. This one, and I can look it up on the internet, and I can see what is my and find a look up here. So I just paste it here, and find it down. So this is down here. That's very simple. We have to check over here. Now, what is the second one? IP version. You can look it up in the IP version here. You can look it up in the IP version. You can look it up in the IP version. See, IP version here, version 4. Some of you can see that version 6, depend on the computer. And if you want to force your computer work only with the IP version 4, I think I will make an announcement for that one. Here, I can follow here this one. Here. I think I made an announcement, right? No? I think I made an announcement. No, that's this one. No. So in the case that you want to force a computer work with the IP version 4 only, you can go to the network and internet setting here. Network and internet setting, you go to internet, you go to chain adapter option, you right click it, go to property, and you unclick this one. So to make sure that your computer only work with the IP version 4. Anyway, I will make an announcement to instruct you how to work with the IP version 4 after this class. So for this one, if you want to tell the question, sorry, if you want to answer the question, you can look it up on this one here. See, tell you internet protocol version 4 here. Very straightforward. What else? What is that? Time to live. You can look it up. You can look it up. What the time to live here? See, you have the time to live here. 1 per day. 1 per day. What else? That use a TCP or UDP. You can look it up again. You can look it up again. You see, for this one here, UDP, because it uses a data graph protocol, and for the net, it uses UDP. What else? What is the short port and definition on that? DNS record type. So you can see on the DNS, on the Wireshark here. Short port here, definition port here, 53. So we work with the DNS. And what's the record? You can see what's the query record here. Record here is the type A, and the type A here. You for the IP with the 4, but in the case of IP with 6, you have A here. Okay, now you can filter based on this one. Delete it. Or TCP port 443 here, the TCP. Anyway, copy it here. I copy this one. Okay, now you see what is the process of the three-way handshake here. I show you how we work with the three-way handshake here. So when you go to the here, I said work everything is TCP only. TCP. I have here. I want to something with the sync first. Yeah, this one. You see, you have the sync first here, right? So if you see for this one here, you can see clearly about the process of three-way handshake. You please show the three-way handshake process here. Now we see sync, sync here, right? Let me see, sync here, and you have the sync and ACK here, and you have ACK here. Now you see the sequence number here, right? You think about this one here. I send the sequence number here, number 0, right? Sync here, number 0. So when he acknowledge, what is the acknowledge number? Yeah, that's why you see ACK here, number 1. And see, that's why we have ACK number 1, and also he send the sync from him also. Things from him also, number 0 here. And when I acknowledge it, I put it at number 1 here. That's why you see, very straightforward with the thing. Remember here, when we remember about sequence number 0 here, it is work in the Wireshark only. To make it simple, Wireshark convert it to 0. To make it simple for you to follow the process here. But actually remember here, actually in the serial line, it is generated randomly. And the randomly is the purpose of security here. They want to know where is the start of the sequence number here. And if you can change it to the real number here. When you go to the preference here, you go to the protocol. You go to the This one is TCP. Yes, this one. Yeah, I click this one. Now it uses a related sequence. That means it convert to 0, right? But I don't use this one here. So I can see actually my number here. You see, in the real life, my number here. Right? It generates randomly. Right? See, you have the 06 here, right? And it's 07 here, right? And this one also 88 here, and 88, 88 here. Oh, this one you will have the data. That's why it not increased by 1 for this one. Okay, so it's very straightforward for this one. What else? Now, if you want to go back, you can click this one. So, if you want to go back, you go okay, so now it come back to 0. Right? It's very helpful for you to follow it. What else? Okay, so one thing here. Well, in the Y sharp also, right? You see when you go to the transport control mission here, and you have a flag here. You see this one seen here, set one. That's why it's a single request here. But this one here, you see, you have the same and you have action. Number 1, that's why it is a single action. So you see, if you look on the flag, you can see what is the message it is. It is a single request, or it's a single act request, or it's an action. Very straightforward, right? You see, for this one also, you have action. Now, what else? So you have to dig it down. You have to dig it down into the Y sharp. You have to dig it down into Y sharp. And one more thing that I want you guys to save this one. I want to save this file and submit it also. So you have to save the file and submit it after you have show work. I made it really. So see, you have to Word document with answer and the Y sharp. Now, I think what else for this one? This one very simple. This one also very simple. This one very simple. And this one, you have to work with the package chaser here. You have to work with the package chaser here. So for this one, you have to submit a Word file and the package chaser file. So remember that in the case of the package chaser here, you have to use the all topology. You have to use the all topology. This one here. So we have to open. You have to add the PT router, add the two switch, add the two PC. So you can think about this one. You add the PT router. You have to go to the PT router here. This one, see, PT router here. Now what else? You have the two of the switch, 2960. So we have to go to the switch, and you have 2960 here. Go to the switch here. And you have the two computers also, right? So you need two more computers, one here, one here. Now you have to connect them together, right? So you have to connect them together. Right? So on each workstation, connect the Ethernet cable F from 0, 0 and connect to the switch F0/1. Right? So you have to remember that you work with the cable here. Like you have to tell you that it's straight through cable, right? Connect the Ethernet cable here, straight through cable. So you connect the straight through cable in the fast Ethernet from this one and connect to the F0/1 from this one. You can do the same with this one here. Now, the first step, right? So on the router, connect the switch F0 to the F0/0 and switch here to the F01 on the router switch. The router connect switch to the button. Now in the router. Do it. Here, connect to the. In the switch, it not tell you which one. This one connect from the absolute start one. Okay. So okay, so I think this one is that follow here. Is that follow here? So in order if you want to go to configure with the router, click on this one, go to the configure here, and this one you have the two interface, right? You can go on this one, configure the IP address, configure the subnet mask. This one also you can do the same. And in the case of PC, if you want to configure for the IP address, you go click on the PC, you go to the desktop, IP configuration, and you put down the information. Okay, so that's all. This one. Now I think this one also. I want to tell something about this one. Okay, the command line here is the command line by CMD, right? You remember that you run at administrator here, you right click it, and run at administrator. So that's good. You can configure the IP address here. The list here, IP config and all show information about what is your IP address, what is the subnet mask, what is the phone gateway, what is DNet information. And if you want to ping connectivity, you can use the ping command here. Okay, for the ping command also. So the ping command, they call it is extended. This is the ping here. So see, you have many options here, right? So if you want, normally you only have the 4 ping, but if you want something with more than that, right? You have more than that here, you can have the add here. You can tell you, if I want to ping for 1,000 times, you can add this here, this call.com, and I put the N here and 100 here. So we do for 100 times instead of 4. See, you have many options for the ping here. Yeah. And as lookup is that you know the IP address, but you don't know the MAC address. Sorry, you don't know the World Wide Web address. Right? So we can use with the ping request also. We can use with a command line here. Cisco.com. Tell you if you want to go to Cisco.com, you go to the IP port here, or you can reverse here. You have the reverse. So that is a Google VNet here. Right? So that's the road. You want to configure the road. Oh yeah, Pete, I tell you, right? Check about the matching between the IP address and the MAC address here. That's the first step. And tracers, I mentioned it already. So I think that's all. That's all for this class today. Any question? Hello?
No questions.
I'm
No.
here.
Yes, you are here. Tyler, are you here? Says that last talk. Here, Tyler here. Matthew, I'm here.
Yeah, I'm here.
I'm here.
Yes, I'm here.
Wait, I'm here.
Yes, I'm here.
And Thomas, I'm here. Okay. So, if you have question, you guys on.
Professor Mitchell is here. He's having some mic issues and he typed in the chat. I just wanted to let you know.
Okay. Okay. Okay, so if no question, I see you guys on Wednesday. And one more thing, I think right now I change the due date for the second part of the week to the Sunday, so we have more time to work with the homework. So you see every part of the module I move to the Sunday, so we have more time to work with the homework.
Thank you.
So see you guys.
Thank you.
Bye-bye.